get started. Can you guys see my screen?
Yes.
All right, so today's lesson is about solving equations, more specifically solving quadratic equations. Okay, so solving quadratic equations using factoring. And as I mentioned before, factoring is going to be used for a bunch of topics. And this is one of them. So we're going to see how to solve quadratic equations using what we learned in the past two classes, which is factoring. So we're going to see how to solve quadratic equations. In the beginning of the semester, we solved first degree equations. But today we're going to solve second degree or quadratic equations. So in the beginning, we'll talk about something like this. That's a first degree equation, or linear because of the power. Quadratic equations are second degree equations like this.
Teacher, is this also part of the midterm?
Yes, everything we cover will be in the midterm. Okay, so this is the form of quadratic equations. There's always the second power. The highest power is the second power. And the left side of the equation is basically a trinomial. Okay, this is what we saw before, a trinomial. We just added an equal sign and another side to it, and it turns into an equation. So let's make this number one definition. And there's an example here. You can say maybe x to the second plus 5x plus c plus 6 is 0. Okay, so quadratic equation. And we'll see how to solve it, find the solutions using factoring. So second degree equations may have two solutions. Or one solution, or none. Okay, it's possible to have no solution for quadratic equations. Okay, so this is basically what we call the standard form. Typically, all quadratic equations have this form. Okay, so whether you see three terms or only two, it's technically in this standard form. And the first thing you want to do before solving a quadratic equation is make it in this form, meaning we need all the terms to be on one side, the left side, normally, and 0 on this side. Once it's in that form, then we use factoring to solve it. So before we get into factoring, let's talk a little bit about something called the zero product property. Okay, something called the zero product or I'm going to refer to it as this. This simply means when you times two things, if you multiply two things, whether two numbers, two expressions or whatever, and you get 0, okay? What does that mean about the values of A and B if you multiply them and get 0? What idea do we get about the value or the values of A and B? If
One of them is 0.
say it again.
One of them equals 0.
That's right. One of them, at least one of them has to be 0.
But before you go there, I'm sorry. What is this in the parentheses, Z, and what are those two things?
PP.
Who?
Zero product property.
Oh, PP.
Okay. So A times B is 0. That means either A is 0 or B is 0. Okay, so whenever you times two things or more, at least one of them has to be 0 in order for the product to be 0. So that's very important.
Is it possible that both of them are 0 or no?
Or both, that's right.
Both.
Or both. Because if both are 0, 0 times 0 would be 0. So at least one of them has to be 0 in order to get 0 from the product. So that's important when it comes to factoring. As an example, let's say you have x plus 2 times some x minus 3, for example, equals 0. So that's the A, for example, times B here equals 0. So that means either A, this factor here, is 0, or this one here, x minus 3, is 0. Okay, so once we do that, we kind of split this into two smaller equations. So now we have smaller equations or first degree. These are first degree equations. We know how to solve these. We did this a lot in the beginning of the semester. So this turns into -2, or so that's one of the solutions. Or here we add 3. We add 3 to both sides. X is +3. So that's it. We just solved this equation, which happens to be, by the way, quadratic. This is a quadratic equation because if you distribute it, x times x will give you the x to the second, which makes it quadratic. We just solved it using the zero product property because we had it in this form. Okay, so we can write the solution set in set notation, same one we used with functions before. So we list all solutions here, starting with the lower one. Okay, so that's the solution set. You can easily check if you plug here, for example, if you plug 3 here, this will be 0. 0 times anything will be 0. Or if you plug -2 here, this turns into 0, and 0 times anything will be 0. That's basically the what we mean by the zero product property. And if the equation is in this form, in the form of A times B is 0, we can apply it right away. If it's not in that form already, for example, this one is not in the form of A times B, what do we need to do to this to make it look like this?
Factor it.
Factoring, that's right. That's why we call this solving by factoring. We have other methods of solving quadratic equations. We have at least 3 other methods. We're going to learn those later, but today we're only going to focus on factoring. So we'll look at the equation, make sure it's in standard form. We factor it. Once it turns into a product like this, then we split it into 2 equations and solve each one of those first degree equations. Okay, so look at this example now. X to second plus 5x plus 6. Again, we can't use the zero product property yet. We have to turn it into A times B, meaning something like this. So to do so, we need to factor this trinomial here, just like we did in the last 2 lectures when we learned factoring. So first, always look for a GCF. We don't have a GCF. We're going to turn this into this. So we need 2 numbers that multiply to what?
2 and 3.
2 and 3. 2 numbers that multiply to +6, add up to +2, would be 2 and 3. Now, as you can see, it's in this form of A times B is 0. So A multiplied B is 0. That means either A is 0 or the other factor is 0. And if you solve this, x equals -2, or x, if you subtract 3 is -3. Okay, so this equation has 2 solutions. So we arrange them from the the lowest to the highest, the lower first.
So for you to check them, would you put -2 plus 2 times -3 plus 3 would be 0 times 0, which equals 0?
Mm-hmm.
Okay.
We can easily check here, or even better if you check here, and you see that it turns into 0. That's the whole concept of this. So we're going to do a bunch of problems with different types of polynomials here, trinomials, binomials. So every time we make sure, again, 3 steps. Make sure the equation is in standard form. After that, we factor it, if it's not factored already. Then that's when you use, apply the zero product property to solve, okay? 3 steps. Every time we repeat those to solve. And this could be any expression, like I said, any polynomial, all the forms of factoring that we learned apply. So the GCF, grouping, trinomial, binomial factoring. So whatever applies, we use. Starting all as always with GCF. Okay, so this happens to be a trinomial. We use trinomial factoring. It may also be, let's say, some binomial like this. Okay, so that's a quadratic equation. The degree is 2. And we check. It is in standard form because all the terms are here, 0 on the other side. What is the next step?
Factor.
That's right. Once we have standard form, we factor. So when we factor, we're going to turn it into some a times b equals 0, whatever this might be. So we're going to, once we factor, we get that.
Could you factor if it's not like what we did up? Can you do the GRE also?
Well, let's factor this now. So what do we look for first when we factor?
The GRE.
GCF.
UCF, sorry.
Okay, so what is the GCF here?
4x.
That's right, so 4 is common. We have x2, x1. So we take the variable with the lower power. There's 2 and 1, we take 1, so 4x. And open the parentheses. Now, what do we do? So we have the GCF.
Then you divide.
That's right, so we're going to divide both these terms by the GCF to factor. So 4x to the second by 4x. 4 and 4 cancel out. x2 by x1 is x minus.
Minus 3.
That's right, 12x by 4x will be 3. X and x cancel out is 0. So now as you can see, we have a product here. So 4x times x minus 3. So this is the A and this is the B. So now we can use the zero product property. If A times B is 0, we're going to turn this into 2 equations. Either A is 0 or B, x minus 3 is 0. And divide by 4. And here we add 3. And these are our solutions to this equation. Again, you can easily check them. At least for 0, you can see if you put 0 here and 0 here, both of these cancel out, will turn into 0. Same if you plug 3, assuming we didn't make a mistake. You should work just fine. Okay, so as you can see here, this is mainly based on factoring. 80% of this is basically factoring. We just add this step at the end of the zero product property. That's why I emphasized before on the importance of factoring. We're still going to be using it for a bunch of other topics. So make sure you understand your factoring very well.
So with zero in that last
That's what I was about to say.
answer, it counts as a solution. So it would be S And then you open the brackets 0, comma 3.
Yeah, you can do that too. You can do put the solutions here. So like I was saying, we're going to be using factoring for a few more topics after this. Make sure you go back to the past 2 lectures, understand those well. Of course, in addition to the rules of powers, because as you can see, we use the rules of powers a lot here when we factor or when we multiply. So make sure you understand those topics.
With 0 as a product, and if we're doing it the way we do it, won't it always work out?
No. Try to plug 0 in the one above. It would be 0 to the square plus 5 times 0 plus 6. So the answer will be 6 equals 0, which is not.
That's right. If you plug 0 here in x and x, these cancel out. You will have 6 equals 0, which is not true. Okay, so it all depends on what you get here. So the only
Thinking the same thing right before you said it.
So the only 2 solutions here are these 2. Only here. By the way, it is possible to get 1 solution only, and sometimes there's no solution. So that's not. If you don't find a solution, that's fine.
Can you give us an example of one solution and non-solution?
Solution, because
Yeah, we'll get. We'll get to that. Here's an example of. Here's an example of one solution. Let's say x to the second plus 4x. And let's say minus 4. So we want to solve this quadratic equation. What is the first step? In
Put
this
it in the standard form.
standard form, that's right. It has to be in standard form. I'm just going to move this over to the other side to write this in standard form. What happens to the negative 4 if you move it over?
It becomes positive.
That's right, negative 4 becomes positive 4. And you have 0 here. Now this is standard form because all the terms are on one side. What is the next step?
Factor.
That's right. So now we're going to factor this trinomial. Do we have a GCF?
no.
It's not GCF, so it's a trinomial. We have 1 here, we have 2. Okay, 1 and degree 2. We can start 2 parentheses, 2 sets like this. And 2 numbers that multiply to 4 and add up to 2 are?
Plus 2.
So
That's right, both
Plus 2, yeah.
plus 2 equals 0. As you can see, this factor is the same as this. So we don't need to say this or this. It's the same thing. We're just going to solve it once. Okay, so minus 2 minus 2. So x is negative 2. Again, no need to do the other one. You get the same number. So this one, as you can see, you have one solution. So S, solution set, just one value here, negative 2. Obviously, if you plug it here or here, you'll get 0. So quadratic equations, like I said, because of the power 2, may have 2 solutions or less. It cannot have more than 2, either 2 or less than 2. It cannot be 3, or for example, or 4, unless you have power 3 here, which we're going to see later. If you have power 3, then you can have up to 3 solutions. Up to 3 solutions if you have a third degree. We're going to do some third degree equations later because they're quite similar to this, even though we said here only quadratic equations, but we're going to do some third degree as well. Okay, so it's very important to make sure you have standard form, make sure you factor, and then, of course, use the 0 product property to find the solution. Any questions, everybody? Are you guys on board?
yep.
Everybody else in the room, got a bunch of people. Is everyone okay? And
Yeah,
please
so
let me
far-
know if you have any questions.
Yes.
Professor, can you do another example of the second one, please?
Mm-hmm.
Thank you.
So let me just we'll go over it. There's nothing crazy about this one. We just moved this over. Okay, becomes positive 4. Then we factored it. So we have 2 factors. They happen to be the same thing. So instead of 2 equations, we just need 1, because if you do 2, you're just going to get the same number. Unlike here, These are different, so each one has a different solution, -3 and -2. But if you factor and you end up with the same thing times itself, so no need to do two equations, you will end up with the same solution. That's basically what this was. We just have to first make this in standard form and move it to the other side. We will have a few others examples here. So let's say 3x to the second plus 21x and probably, let's see. Okay, so we have another quadratic equation. We want to solve this and find the solutions. Again, make sure it's in standard form, which it is here. Standard form again means 0 here on the left side. Everything else here, unless you have something here, then you can move it just like we did here. So it is in standard form. The next step is to, what do we do now after standard form?
Factor.
We factor.
That's right, we need to factor. Factor this trinomial. Okay, so how do you factor this?
With GFC. There is no GFC, there is?
Yes,
Oh.
3.
Oh yeah, there is.
Always
Three.
our GCF, that's right.
Sorry,
We
GCF.
factor, we need
3.
GCF. Okay, and look for that first. If this doesn't work, then, or if this doesn't work, or if it does work, then you try to see if you can use grouping, maybe trinomial, maybe binomial, depending on the trinomial really. So in this case, the GCF here is 3. So we're gonna write 3 outside. Nothing else is common. The x is not common because it's not here. So we try the GCF first. Open the parentheses. And what do we do with these 3 and the GCF? We will divide all of them by 3. So 3x to the second by 3. 3x to the second plus 21x by 3. 7x plus 12. Good, so we did GCF. Can we factor this more? Can we factor this trinomial more?
No. We can.
Yes.
Yes, we can. No?
Yes.
Yes.
We have one
4
here.
plus 3.
Figure out two numbers are multiplied to 12, add up to 6,
X plus
3
X
and
plus 4 and 3.
right? Plus 3 plus 4. And now we can go ahead and use the zero product property. So we have 3 factors here. We have 3, we have x plus 3, and x plus 4. Only 2 of these can be 0, not this one. This is a constant, doesn't have x, so this will never be 0. It's just 3. So if these
So
two multiplied are 0, that means either this one is 0 or that one is 0. This can never be 0. So we can turn this into 2 equations. Okay, just like we did in the previous examples, and we solve each one. So this means x is -3. Or x is -4. Okay, so always, again, do your GCF first. After that, if you can, use another method. So you have to factor completely before you can solve. Because each factor with x will turn into an equation. This one, this one. This one doesn't have x. But if this one had an x, for example, next to 3x, then you would write a third equation. But 3 is a constant. It does not turn into 0. Okay,
Because
so,
we want to know what x is, basically.
I'm sorry, say it again.
Now, I'm saying in regards to the constant, we want to know what x is. That's why we're not looking at the 3.
That's right. Only something that might be or can be 0. For example, x can be, yes, so this may turn into 0 if x is -3. This might turn into 0 if x is -4, but this will never turn into 0 because it's a constant, unless it has an x next to it. For example,
The 3rd degree
we take
equation.
this example here, x to the second,
Mm.
and maybe -x. Or just x. And possibly, let's see. Say this, for example. Okay, we have x to the second equals -x plus 6. So quadratic, again, we want to solve it. What do we do first?
Under form.
That's right, so we're going to make sure all the terms are on one side. So we're going to move both of these to the other side to write the equation in standard form. So this turns into x to the second. -x moves to the other side, it becomes +x. And +6 moves, becomes -6. Okay, make sure you change the sign when you move something to the other side of the equal sign. It is now in standard form. Let me actually, this is not what I meant to. Let me change the powers a little bit. So let's make this 3, 2, and x here. 3, 2, and also x. This one happens to be actually a 3rd degree equation, not just a quadratic 3rd degree. Same steps as the quadratic equations. Make sure it's in standard form, then you factor and use the 0 product property.
So the last one is 6x? Sorry.
Yeah, 6x. So we move both of these to this side and change the sign, okay? Negative becomes positive, becomes negative. That's the first thing. Next thing, just like a quadratic, we need to factor. So look at these. Do we have a common factor?
X.
Did you see it? That's right, we have x. We have x3, 2, and 1. Which one do we take as a common factor?
X.
X.
That's right, so we're going to write x, open the parentheses. And what do we do now?
X to the second.
X squared plus x minus 6.
That's right, we're going to divide all of these by the GCF. So it'll be x to the second plus x minus 6 equals 0. Are we done factoring, or can we?
No, we could do some more.
So what do we do exactly?
So we're gonna put bring down the x and then parentheses x.
That's right. So we can
Plus and minus 2. Excuse me, minus 2 plus 3.
Minus 2 plus 3. Two numbers are multiplied to -6. If you combine them, you get +1. There's an invisible +1 here. Good, so we factored completely. Now we can go ahead and use the 0 product property. How many equations are we going to have to solve?
3.
3.
3 equations. Yeah, this one has x, this one, and this one. So 3 factors, all with x. Unlike this one didn't have x, that's why it didn't matter. Only these two mattered. But
Could it be that the first x has a solution of 0? Like, because
Yeah.
then multiply everything else and it would be 0 anyways?
Yeah.
just like a times b. If you have a times b times c or more, at least one of them is 0. In order to get a product of 0, either this, or at least one of them, if not all of them, or 2 of them at the same time. So you have 2 or 3 equations. So either x is 0, or x minus 2 is 0, or the other factor.
So you would have 3 solutions here then?
That's right, we can have 3 solutions. So this one is already solved here. There's nothing we need to do to the x. It's already there by itself. Here, x is 2. For this one, x is -3. So as you can see, as I said earlier, when you have a third degree, expect to have up to 3 solutions. If not, sometimes even you can have less than 3, but you cannot have more than 3. Now we can combine these together in set notation. So set name, colon, curly braces. And we list all solutions from the lowest to the highest. So which one goes first?
-3,
Then
0, then 2.
and 2. So that's basically, it's not that bad to solve third degree equations. Even if it's some higher degree, try to factor as much as possible. If you turn the equation into factors, multiplications of factors like this, then you can split it into smaller equations and solve each one of them. Okay, so because like I said before, it's the same process every time. Standard form, factor, and the zero product property. And again, this is just solving by factoring. We have other methods of solving, but we're going to learn those another day. Here's another possible scenario. It's possible to have something like this. Let's say x plus 2 plus 3. If you look at this equation here, so we have second degree, okay, it's quadratic. Can we use the zero product right away?
No,
We cannot. Why not?
because it's not equal to 0.
That's right. So you cannot turn this into 2 equations right away unless we have 0 here. So it's called the zero product property for a reason. Okay, so the 0, meaning there has to be a 0 on the other side. If you don't have 0 here, this does not apply. So here we cannot go ahead and turn this into 2 equations right away because of this. So what we're gonna need to do is, so what do you think we need to do here?
Move the 14 to the other side.
That's right, we need to bring the 14 to the other side.
You know, come out to positive, right?
Yeah.
So it's positive. But before we do that, we need to expand or to distribute this, then bring the -14 over to combine it with some number here, some constant. So let's make it look like this first. Then when we bring the 14 over, we will combine it with the number. Okay, not right away. So let's distribute this. If you distribute, I get x to the second plus 5x plus 6. Okay, so 2 numbers are multiplied to 6. 2 numbers add up to 5. Now we can move this over, so we can combine it with 6. Positive 6 positive plus 14 would be let's see, I meant to put, okay, so the numbers might not add up exactly as I expected. I may have to change this into something else. So we could end up with a trinomial. So if we combine these, we get 20. And let me, want to get here, I need to make this, let's continue and see what happens. So this turns into 20, right? Now we need 2 numbers that multiply to 20 and 5. Apparently we can't find those. I made this up. This should have been This should have been 9 here. 9, 9, 9 to make things convenient. So let's turn this into 4 and 5. Let me redo this. Let me do this with a different example, so we don't run into something like this. So let's make this maybe hopefully this will work. It should. Yeah, this should be okay. So let's do the same thing. Okay, just forget about this example here. So I'm making up all these examples as we go. I'm not looking at anything. Hopefully this should work. Again, we can't use the zero product property. We need to have the equation in standard form, meaning 0 here and all that, the terms on the other side. So before we move the 14, let's distribute this. This will be x to the second plus x minus 6 and 14 here. So now we can move the 14 over. Becomes negative 14. We can combine these two here. So x to the second plus x minus 20 equals 0. Can we now factor this? So now it's in standard form. What do we do after that? We need to factor. Okay, so there's no GCF. We need two numbers that multiply to negative 20 and add up to 1.
5 and 4.
That's right. What signs?
Plus 5 minus 4.
That's right. Positive 5 and negative 4. So if you times them, we get negative 20. If you combine them, 5 minus 4 would be 1. Now we can use the zero product property. So either this one is 0 or that one is 0. X is negative 5 or X is 4. Okay, so that's basically what we do when you have a situation like this, where even though it looks like it's factored here, but it isn't, we need to have a 0 here before we can solve. And you might even have, it's possible to have 2 of these, this and something like this on the other side, just like this. So you'll have to distribute both and move all to one side. So if you have another set of parentheses here instead of 14, same way. So you got to distribute everything, combine all your terms on one side, and then factor. It's always going to be these 3 steps: standard form, factor, and use the zero product property to solve. Any questions, everybody?
No.
Okay. Everybody else, are you guys okay? Please let me know if you have any questions.
I think I'm getting it now.
No questions.
Mm-hmm. So again, this is mostly about factoring. I can't emphasize enough how important it is to understand factoring the past 2 lectures. It will make the rest of this and the next few classes a lot easier, and will make them make a lot more sense.
Let me copy the last one.
Mm-hmm. Okay, everyone, if you don't have any questions,
Professor,
let's see if I give you some practice. Yes?
so we'll have a review of the exam, midterm exam.
Yes, the review is posted. It's posted.
Oh, you have already posted? Okay.
Over a week ago.
Okay, thank you.
Work on it. It's in the homework folder. Work on it, everybody. If you have any questions from it, we will do a session of review before the midterm. So the exam again is next week on Thursday. So work on the review sheet. Up to where we are right now, only what we have covered so far will be in the midterm. All right, so let's do,
Thursday, I'm sorry.
yeah, it is on Thursday.
Okay.
Next week would be week 9. Okay, solve. Okay, the question will specify what method to use. So in this case, we only know to solve by factoring, but in the future, we're gonna learn 3 other methods. And you always go by what method the question is suggesting you to use. It has to be the exact method here. If I say a factoring, you use factoring. If I say some other method, quadratic formula or some other thing, then you use it. But today, again, we're just doing factoring, so solve these by factoring. So x to the second. Okay, and finally, all right, so that's your practice here. Similar problems. Okay, I'll give you a few minutes to work on this, and I'll check with you when you're done. Okay, everybody, let's go over these together. So what did you get for the first one here?
-5 and -2.
-5 and -2, that's right. So first we factor into this. We have two solutions, x -2, x -5. And what about this one? What do you do first?
I moved the 36 to the other side, changed the sign.
Exactly, it has to be in standard form. So we're gonna move the 36 over, change the sign, then factor. What is the factored form?
-6, +6.
That's right, x minus 6 is plus 6. This means x is 6, and this means x is
-6.
-6. And here?
So you just want the solution?
Or factor first, what's the GCF?
Okay, 6x.
6x.
Mm-hmm. And
X
X minus 3.
x minus 3. That means x is 0. Or x is
3.
3.
3.
Very good. And now let's look at this one. What do you do first?
Turn it into standard form.
Right into standard form. That's right.
X to the second plus 12x plus 36.
Mm-hmm. Okay, so what's the factor form?
X plus 6.
Plus 6. One solution.
That's right, just one solution because these are the same. So we're just going to solve one of them. So x is -6. And over here, for this one, what do you do first?
Factor.
That's right.
3x. Parentheses.
Yes.
X squared minus x minus 6.
That's right. So 3 minus x minus 6 is 0. And
3x.
Factor some more.
factor more,
X minus 3, x plus 2.
x plus 2.
So the solution is -2, 0, and 3.
That's right. We have three solutions. One from here, x is 0, x is 3, or x is -2.
-2.
And we have one left here. Okay, what's the first thing we do here?
Unfactor.
Okay, which means
Distribute.
multiply, right?
Yeah, distribute.
The opposite of factor is multiplying or distributing. So this x to the second
Minus
Minus
x minus 6.
Oh, you.
minus 6.
Okay.
Then we move this over.
Mhm.
Minus x minus x minus
Minus
6.
6
0.
is squared minus x minus 12.
Minus 12. And then
X plus
x
x minus
4
4.
and x plus 3.
plus 3. Okay, so the solutions are
4.
3 +4.
4, x is
-3.
-3. Okay, see how factoring makes everything easy. Okay, all these equations may look complex, but they're not. It's all about factoring. So I'll post this lecture along with the homework. So I suggest that you guys rewatch it before doing the homework.
This is a part of the midterm.
Yeah, everything we cover will be in the midterm. And yeah, so work on the review sheet. Try to do all the problems there. You have the answer key in the.
Are you doing midterm review on Tuesday?
Yeah, on Tuesday, I'm gonna go over the questions you don't understand from the review sheet. So, but work on the whole thing. It shouldn't be that hard. Look up to your notes, the lectures, and try to do all the questions from there. The exam will be based on it. It will be quite similar to it. So we may not have time to do all the questions from the review sheet. I'm just gonna do a few from each section, a couple from each section. So make sure you work on the whole thing and study all the questions there.
How many questions are going to be on the exam?
20.
Mm,
Okay.